We will now use logarithmic differentiation to find the derivative of y. We have y equals 4th root of x squared plus 9 over x squared plus 10. So first, let me rewrite this expression on the right side. So I put y equals, I can rewrite this using the exponent laws. That is, we can rewrite this as x squared plus 9 over x squared plus 10. And when we write this in exponent form, we raise it to the power of 1 by 4. So now we can apply natural logarithm to both sides. So we apply natural logarithm to both sides. And when we do that, natural logarithm of y, we write on the left side. And here we apply natural logarithm, that is natural logarithm of x squared plus 9 over x squared plus 10. And this is raised to the power of 1/4. Now I'm going to apply the power rule of natural logarithm, and when I do that, I can put this power in front. So I'm going to write that in the next step. So I write natural logarithm of y, and this equals 1/4 times the natural logarithm expression, that is natural logarithm of x squared plus 9 over x squared plus 10. Now let's simplify the right side expression. So on the left side, we have natural logarithm of y, and this equals 1/4 times, I'm going to put this bracket. We can use the properties of logarithm. That is, if we have natural logarithm of a over b, and this equals natural logarithm of a minus natural logarithm of b. So I'm going to use this quotient rule of natural logarithm. So when I use this, I can rewrite this as natural logarithm of x squared plus 9 minus natural logarithm of x squared plus 10. So we have simplified the right side expression. Now we can find the derivative on both sides. So here, to find the derivative of natural logarithm of y, we can use the natural logarithm of x derivative, and this is equal to 1 by x. So first I put 1 by y, and then we apply the chain rule to find the derivative of y, which is y prime, and this equals, we have 1/4 here. Now we can find the derivative term by term. So here we have this natural logarithm of x squared plus 9. So using the same rule as well as the chain rule, we can write this derivative as 1 over x squared plus 9. And then when we apply the chain rule, we find the derivative of x squared plus 9, and this equals 2x. So we multiply with this 2x. We are done with the derivative of the first term. Now let's do the derivative of the second term. Once again, we use the derivative rule of a natural logarithm. So I put 1 over x squared plus 10 times, we apply the chain rule to find the derivative of x squared plus 10. And this equals, once again, it is 2x, because the derivative of x squared is 2x. So we multiply by 2x here. You see that we have the common factor 2x in the brackets, which I'm going to factor here. So on the left side, we have y prime over y, and this equals 1/4. I'm going to factor 2x. When I do that, I get 2x times of 1 over x squared plus 9 minus 1 over x squared plus 10. We can simplify this expression. Let's do that. So we have y prime over y, and this equals, this can be simplified. So it is x over 2, and here we can simply cross multiply. That is 1 times with this factor, as well as negative 1 times with this factor, and then multiply these two terms in the denominator. So therefore I put x squared plus 10, and minus of 1 times of x squared plus 9 is minus x squared minus 9, and this is all over the product of the terms in the denominator, which is x squared plus 9 times x squared plus 10. Let's simplify the terms in the numerator. We see that x squared gets cancelled with the negative x squared, and 10 minus 9 is 1. So we just have 1 in the numerator. Let's put this in simplified form. So we have y prime over y, and this equals x by 2 times of 1 over x squared plus 9 times x squared plus 10. And since we want to find the y prime, I'm going to multiply both sides by y. So therefore, we will have y prime on the left side, and this equals y times of the expression on the right side. That is 1 over x squared plus 9 times x squared plus 10. And now we have to substitute the value of y. So on the left side we have y prime, and this equals, we can replace the y as we have written in this form. I'm going to replace this y in this form. So it is x squared plus 9 by x squared plus 10 raised to the power of 1 by 4, and then we have x by 2 multiplied with 1 over x squared plus 9 times x squared plus 10. We can put in a simplified form. So first let me put this x by 2 term, and then I'm going to apply the exponent law here, which means I can write down this as x squared plus 9 raised to the power of 1 by 4 divided by x squared plus 10, once again raised to the power of 1 by 4. And then this is multiplied with the expression, which is x squared plus 9 times x squared plus 10. Now let's combine the like terms, the numerator and denominator, using the exponent laws. So therefore this equals, I can put this as x by 2. We have x squared plus 9 raised to the power of 1 by 4 in the numerator, and x squared plus 9, this is raised to the power of 1 in the denominator. So suppose if we have a raised to the power of m divided by a raised to the power of n, we can write this as 1 over a raised to the power of n minus m. That is, we can bring this term down here, and when you bring it down, it becomes a raised to the power of negative m, and we already have a raised to the power of n. So therefore when you combine these two, we get a raised to the power of n minus m. So basically I'm going to do this subtraction here. So I'm going to put 1 over x squared plus 9 raised to the power of 1 minus 1 by 4. Basically, I'm bringing this 1 by 4, this term down here, so it becomes negative power. And also, we do the same thing for the other term, but here these two terms are in the denominator. So here, this 1 by 4 will get added with 1. So let me put that. So it becomes x squared plus 10 raised to the power of 1 plus 1 by 4. Let's simplify this further. So this becomes x over 2. Now we have to simplify this fraction, 1 minus 1 by 4, and this basically equals 3/4. So I'm going to put 1 over x squared plus 9 raised to the power of 3/4, and then multiplied with x squared plus 10, and we have to add this fraction, that is 1 plus 1 by 4, and this equals 5/4. So I put 5/4. Now we can consider this as the derivative of the y. This is one form of the answer. So we say that this is y prime, or else we can also give it in a different form. So I'm just going to write down this answer in a different form. So I put y prime, and this equals x by 2. Notice that we have this x squared plus 9 raised to the power of 3/4. I'm going to rewrite this as x squared plus 9 raised to the power of 3, and once again raised to the power of 1/4. And similarly, I do the same thing for the other term, that is x squared plus 9. This 5/4, I can write down this as raised to the power of 5, once again raised to the power of 1/4. Now, I'm going to use this rule, that is, if we have this a power m raised to the power of just change this to, this has to be b power m. So this is one of the exponent law. That is, if we have a power m times b power m, and this could be written in simplified form as ab raised to the power of m. So likewise, we can observe that we can consider this expression, that is x squared plus 9 raised to the power of 3, as a, and this one x squared plus 10 raised to the power of 5 as b. So here we have a raised to the power of 1/4, and here also we have b raised to the power of 1/4. And this means we can combine these two and put it as the power of 1/4. So I'm going to write down y prime, and this equals x by 2. We will combine this as a single denominator. So it becomes x squared plus 9 raised to the power of 3 times x squared plus 10 raised to the power of 5, and this is complete raised to the power of 1/4 as I use this rule. So now we can also rewrite this in a kind of radical terms. So x times 1, I can put this as x, and this is all over 2 times of, since it is raised to the power of 1/4, I can put this as under the root. This is under the root 4, and inside we have x squared plus 9 quantity cube, and x squared plus 10 raised to the power of 5. You can just erase this part. So it is basically this under the root, and this is raised to the power of 4. So I put this 4, you can put this 2. So it is, this is the answer, and this is the derivative of y in a different form. You can also consider this as the different form of the same answer which I have already given, this one or this one.